Okay, let's keep rocking through with a little bit more probability, but we're going to be more specific with our probability with this time and talk about specifically the binomial probability distribution. All right, so we're going to narrow our view down here a little bit with this binomial probability distribution. Not any, but this specifically, the binomial one, because just like everything else, we're going to keep adding to it. We've talked about a probability distribution. We've worked through that stuff. Now we're going to talk about different types. And so here's a specific type. So the criteria for a binomial probability distribution, and it's called this because it has to meet these 4 criteria. So if any of these 4 criteria are not met, then you're out. Right? Then that's not a binomial probability distribution. It's not a binomial experiment. Boom, you're done. So it has to be, pardon me, I said that a little different. It has to be a binomial probability, experiment in order to be a binomial probability distribution. Crazy, right? Okay. So it has to meet these 4 criteria. Once those criteria are met, then I can look at the probability distribution. All right, so let's do this. So the experiment is performed a fixed number of times. Each repetition is called a trial. So it can't be just an infinitely many number. You have to have a specific number that has to say that. That's what fixed number means, a specific value. The trials are independent. That means no outcome of one affects the outcome of another. So they have to be truly separate trials. All right? For each trial, there are 2 mutually exclusive options, either failure or success. And I said those backwards, success or failure, 2 options. That's the bi part of this. It's a binomial probability distribution. This criteria 3 is what makes it in specific to be a binomial probability. 2 choices. That's the bi part. So if you look at Latin, right? That means 2, and that's how many choices you have. That's what narrows this down as criteria 3. Then criteria 4 says the probability for success is the same for each trial. So they're all independent, and you can be successful every single time. So the option for success is there. All right? Okay, now look at some notation, because you know it's stats and it's math, and so we have notation, and that's part of it. So there are n, which we know to be the sample size, right? There are n independent trials. We're going to let P denote the probability of success. So 1 minus P is the option of failure. What is 1 minus P? That's just a complement. What do we know about a probability? They all add up to 1. Right? This is not brand new information. P is going to be success. Well, what's the other side of it? If I only have 2 choices, what's the other side of it? Failure. And if I have a probability, they all have to add to 1. So I'm going to use the complement to get the other part of it. Right? Okay. Right? It's not that bad. We've got this. We're going to let X denote the number of successes in N independent trials of the experiment. So X has to be the number of successes here. The number of successes has to be less than or equal to the total number of trials that we're doing, because we already denoted that. All right, well, no duh, right? I can't have more successes than the options I even have available. I could have total success, right? It could be total success. That's why it's or equal to, but I can't have more than that. All right, so first and foremost, we're going to determine, because before we can even do a distribution, we have to make sure it's an experiment, right? I'm going to scoot this up so we still see those 4 criteria. We want to determine if the following probability experiments qualify as a binomial experiment, because if it does, all this rings true. For those that are binomial experiments, identify the number of trials, probability of success, probability of failure, possible random variables X, right? Okay, so step 1. That we're looking at this. We want to see, is this success, right? Is this a binomial experiment? And that's what we have going for us here. All right, an experiment in which a basketball player who historically makes 80% of his free throw goals is asked to shoot 3 free throws, and the number of free throws made is recorded. Oh my goodness, I almost got super tongue-tied there. Let's look at our criteria. Criteria number 1, the experiment is performed a fixed number of times. Is this a fixed trial? Fixed trials, fixed number? Yeah, they're going to shoot 3 of them. So N equals 3. And that's what we're looking at, right? So we are identifying the number of trials. Number 2, we're doing this as we go through here. Number 2, the trials are independent. Are they? Yeah, each free throw is independent. One does not depend upon the other. So each free throw is independent. Because it's the same guy shooting it, it is what it is. Number 3, there are 2 outcomes, success and failure. Do we have 2 outcomes? What would success be? That you make the basket, right? What would a failure be? That you miss it, yes. Yeah, 2 outcomes. You're either going to make it or you're going to miss it. That's the only 2 options. Right? Even if it swings around the rim, if it doesn't go in, that's failure. If it goes in, that's success. So no matter what, you're going to have those 2 options. The 4th is what is the probability for success is the same for each trial. What's the probability for success? Yes, it's this 80 because it says historically makes 80%. But do I write a probability as a percentage? No, we have learned that and we've said that over and over again, right? So what's the actual probability that he's gonna make it? 80%. So 0.8, right? Or 0.80, same thing. Well, if the success is 0.8, what's the probability of failure? It's the complement, remember? So if success is 0.8, what's failure? 0.2, yes, because 1 minus 0.8 is that 0.2, right? And what, if I'm looking at this, the last thing is, what are the possible values? I'll have to go over here to the side because I ran out of room. Possible values that we're looking at here. X is what? What are my options for these free throws? Like what could happen here? He could make 0 of them. He could make 1, 2, or all 3, right? Those are your possible values. Is this a probability, a binomial experiment? A binomial experiment? Yes. It is a binomial experiment. And now that we have looked at this as a binomial experiment, then we have identified all of these options that go with our notation. Cool, right? That's the big deal. Can you hit those criteria? Boom, then you've got it. Okay, let me squeeze this in so we can still see those 4 options. And let's do this next one. According to a recent Harris poll, 28% of Americans state that chocolate's their favorite flavor of ice cream. All right, I can dig that. Suppose a simple random sample of size 10 is obtained and the number of Americans who choose chocolate as their favorite is recorded. All right. Do I have a fixed number of trials? Yes. How many is that? 10, right? Because my sample size is 10. So we're looking at 10 different options here. Is the trials independent? Yes, right? We're not asking the same person. We're asking all kinds of different people, right? Yes. We're asking different people. And here's the deal. With a large population, independence is understood. So let's just put that in here. With a large population, independence is understood. Try again. Oops, it's not writing. Gosh, that looks really bad, doesn't it? Independence is understood. All right, so yes, we're asking different people. That makes an impact, and it's understood that there's enough people out there that it makes an impact. All right, what are my outcomes? Do I have two outcomes? The question is, state that chocolate is, suppose a simple random sample obtained and the number of Americans who choose chocolate as their favorite is recorded. That part. And as the number of Americans who choose chocolate as their favorite is recorded. So do I have a success and failure here? Yes, chocolate's my favorite. No, it's not, right? Those are my two options. It doesn't say, this is not an open-ended question. They're not saying, we're going to go out and ask people, what is your favorite ice cream? That's not what's being asked here. What's being asked is chocolate your favorite? That is binomial. Do you see the difference? Okay, so if it just says, I'm going to go out and ask, what is your favorite ice cream? Nope, not happening. But this one is legit. Okay, so success, would be what? Like, what do we, chocolate is favorite. And I'm running out of room here. I should have made more room on this page, right? What's my failure? Not chocolate, yep. I don't care what it is, just the fact that it's not chocolate, right? Those are my two options. All right, so then I have to say, is the probability for success the same for everybody? So what's the probability for success? Yeah, 28%, because that's what my problem tells me. So, yes, 0.28. Good, because it has to be a decimal that we're looking at. All right, what's the probability of failure? Yeah, it's the opposite of that. So 1 minus 0.28 is 0.72. Nice. Guys are amazing. You guys are amazing. I'm going to scoop this up. I feel like it's so small. Okay. So what are my possible values? I'm going to change color because it's getting too crazy. Hopefully you guys write nicer than I do and you have plenty of room. Possible values. Right, that we're looking at. Possible random variables of those that choose chocolate. That's what we're looking at here. Those that choose chocolate. That choose chocolate. How many could choose that? 0, 1, 2. Out of how many do we have total? All the way up to 10. Good. I'm not going to write all of those. But those are my possibles. Nice. I'm going to write the word values so that you can actually read that it says values. That's helpful, isn't it? So is this one a binomial? Yes. It's a binomial experiment, and then we can get all that stuff out of it. Good. Good. Okay, one more. A probability experiment in which 3 cards are drawn from the deck without replacement and the number of aces is recorded. Okay. Do I have a fixed number? Yep, 3 cards. Do I have, what's option 2? Are these independent? No. Do you see that? Without replacement. Ooh, snuck those words in there, but they make a huge impact, right? So this is not a binomial experiment because the trials are not independent. When you take one card out, that changes the probability for the second card. One card out, it changes the probability of the next card. So they're not independent and the probability changes. So we have knocked ourselves out on 2 and 4 criteria, right? So this is not, ooh, my thing's moving around on me. This is not, that says not. I tried to put a box around it to make it look cool and I failed. Not a binomial experiment. That's better, right? Cool. So we get the criteria at least. That's a good thing.